Okay, finally, a first example of using integration by parts. The integral of x times the cosine of x dx. Now, if you are tempted to integrate each one separately, even though they're multiplied, that might be a clue that you're using integration by parts. We don't know off the top of our heads whose derivative is x cosine of x. U substitution, what are you going to set u equal to? You set it equal to x, you're just changing your variable. You set it equal to cosine of x, you're going to need a sine of x dx floating around. You don't have that. So, what do? We set u equal to something. And Lippitt says logarithms don't have it, inverse trig don't have it, polynomials we do. Set u equal to the x, and du equal to everything else, dv. dv equal to everything else, cosine of x with the dx. Now remember our formula. Our formula is integral u dv equals uv minus integral of v du. So we need to know what du is and we need to know what v is. So we take the differential of u. If u is x, then du is just 1 dx. I'll write it as just dx. If dv is cosine of x dx, we integrate both sides to say v is the integral of cosine of x. Whose derivative is the cosine of x? Sine of x. No dx left. So then we use our formula and we say that the integral of x cosine of x dx, that's your u dv, is uv. Now if you put it in this order, u up in the upper left hand corner, dv, and then you take the differential down and the integral up, then it's going to be uv minus across the bottom. So it's going to be x sine of x minus the integral of v du, which is sine of x dx. And that is easier to integrate because we know whose derivative is sine. Negative cosine is the integral of sine. So this is x sine of x minus, and what is it? Negative cosine has the derivative of sine. Right. Plus your c at the end, and so we end up with x sine of x plus cosine of x plus c. And we say, really? Maybe. Let's check. If we check, we say, what is the derivative of x sine of x plus cosine of x plus c? And we have to use the product rule. The derivative of x times the sine of x, it is the derivative of the x, which is just 1, times the sine left alone, plus the x left alone times the derivative of the sine, which is cosine of x, plus the derivative of cosine is minus sine of x, and the derivative of c is 0. And the sine of x cancels out with the minus sine of x, and the 0 doesn't do anything. We are left with x cosine of x. And that is exactly right. This thing has as its derivative what we wanted. And that's how we know that this is the right answer.